Hi, everybody. Good evening. First of all, thank you, Dalia, for organizing this great meetup. It's the first ever marine data meetup, so it's exciting. The industry is quite small, and apparently everyone knows each other, so it's pretty cool to see. I will start by saying some thanks. First of all, thank you, Tamir, our system engineer at Orca AI, for helping me achieving one of my dreams. Second of all, thank you, Dalia and Google Campus and Windward for sponsoring all of this. And third and last but not least, thank you both my parents. They just landed today from Australia and they just came here. They're super tired, I can see that, but they're sitting here. So thank you, Mom and Dad. My name is Do. I'm a co-founder and a CTO of a newly founded startup called Orca AI. A little bit about what we're going to talk about today. So setting sails towards autonomous ships. Interesting subject. A little bit about Orca. We secured our first finance round of $2.5 million in July. So it's not a long time ago. It was founded by me and one of my best friends from the Israeli Navy. We're both naval instructors in Haifa. And the team, one of them is here, but the team consists of R&D mainly, software engineers, algorithm engineer, and a system engineer. And we're sitting in Rothschild in Tel Aviv. And we are growing, so ping me up later maybe. So, the oceans are huge, right? We don't see things like that happen every day. There's a lot of space to sail all around the ocean. Yair even mentioned in his lecture, did you see how many ships were near Italy? So maybe there are a lot of ships at sea, and maybe things like that actually happen. This is a picture of a Norwegian warship that collided with a commercial ship near Norway, and the ship was lost. And it cost $400 million. Warship. The entire 140 people of the crew got evacuated because someone didn't pay attention to what's going on outside. Oops. Why is it happening? Usually because you need to be an expert at sailing at sea. It's not something that everyone can do like really good without any expertise. So you need to be able to operate different sensors like radar, like AIS. This is the AIS. Binoculars, which is hard to operate. All right, so let's return to today. We're 2019. Let's talk about some buzzwords, because everyone loves buzzwords. Autonomous cars, happening right in Herzliya, in Tel Aviv. Autonomous trucks, roaming the entire roads in the United States. Autonomous drones, mapping construction sites. Autonomous everything. Why not autonomous ships? But it's quite hard, because the marine domain, even though it's one of the most ancient, I would say, domains in the world, people have been shipping goods since the dawn of time. It's one of the oldest in the world. It's actually a key to some interesting concept that we all know and love today, like insurance companies. They started for the marine domain. Supply chain, something that's very interesting for all of us, but it's also started over there. And many other interesting concepts, like the commercial flight domain, captain, cockpit, deck. It's all from ships. The problem is that there are almost no standards in the field. And why is that? When you go up on a commercial plane nowadays, you know it's going to be an Airbus or a Boeing, right? In ships, it's not quite the same. Why is that? Historically, there are much more shipyards throughout the world. The Chinese are actually building ships very differently from the Finnish, and every ship transfers different goods in different locations of the world. So a ship that's designed to sail the Baltic Sea near icebergs is not suitable for sailing in the Caribbean Sea, where the humidity is like fun. And the latest technology achievements in this field, due to the lack of standards, because it's hard to put new software, new technology in a generic way on ships, means that the latest technology jumps were actually the radar, the AIS, the GPS, and the latest update, you can go out without paper maps on board ships. This is really recent. It's really technological advantage. So, Orca inspired by the autonomous domain, autonomous cars domain, and we actually aim to develop intelligent collision avoidance system based on deep learning, because deep learning is the thing now, right? We would love also to alert on possibly dangerous situation, and maybe even provide a nice recommendation that the captain itself would have think of. But we'll talk about autonomous ships later, because no one's taking autonomous ships now. They're not ready. When you go out to a shipping company and say, hey, I'll make your ship autonomous without anyone on board. And he's like, yeah, no. I have 7,000 cars on my ship. No, it's going to be sailing with people on it. No, don't worry. So, why deep learning at all? Right? So people try to do situational awareness using classical computer vision methods. But like Vicky told earlier, the number of variables is just too high. You cannot converge on a simple pattern of rules to catch all the edge cases in the marine domain. And why is that? Because the variability is just too high. Too many edge cases. So, deep learning for the rescue, it's great for generalization. Feed it data, it'll solve everything, especially real-world problems. So, one nice example that I always love to show is, we clearly, all of us can see that this is a boat, right? Yeah, pretty easy to see. Yeah, it has its own like little mast here, the bridge, but this is also a boat, right? What about this? Are they looking the same? Can we build a rule-based algorithm to identify the difference between these and concur that these two are ships? What about this one, this guy? Is this a ship? This looks like a ship. But no, it's actually a lighthouse that's connected to ground, right? So maybe try to write a classical algorithm that looks for masts and contours and I don't know what. Not gonna work. Sorry, guys. What about other challenges like horizon detection, right? We want to maybe calculate distance to other objects. It's a nice reference point. Where's the horizon in this image? Is this one? Clearly, right? But maybe this one as well? What is horizon? Is it the difference in the colors, like change of colors? This is a bad example to run your horizon detection algorithm on. As well as here. This is pitch black darkness. You can almost see nothing. Think of the noise from the sensor. It's a hard case. Icebergs. The guys at the Titanic did a great job of identifying icebergs, but it was a bit too late. And icebergs actually are very interesting because no iceberg look alike. They are all different, but maybe we can count how many white pixels are inside the iceberg. So here, I don't know, 20,000 pixels, 30,000. How many here? I don't know, 5,000? Is it still an iceberg? For us, it's trivial, right? It's easy, but for machines, it's harder. So, deep learning for the rescue, no problem at all. Just collect a lot of data. How do you do that? Let's look at public data sets. Microsoft Coco, the largest data set in the world, 18 million images, 3,000 boat images. Most of them are not even boats, sorry. Yeah, kayaks. Okay, so let's go on a ship. It's not that easy. No one just, hey guys, come over to my ship, put your cameras here, no problem at all, and just look outside at what my crew is doing. Yair can tell you all about how many people at ships want to know what their activity is. Okay, so we got up on a ship. How do you build a data collection platform? And how much data are you actually generating using this method? So we went on a ship. Me and Tamir over here, a system engineer, he's going to be the star of this presentation because someone had to take all the pictures and someone was the star. So we got up on a huge car carrier, and this is Tamir, and someone is taking his luggage. And they put a stamp of a ship on my passport, which is pretty cool. And this is the ship we went on. It's a 190-meter-long car carrier. And we build our external data collection platform using חצי bet in English, I don't know how to say, and putting a מדבקה, a stamp on the system, and building a T-shape using security cameras that we bought in Alibaba. Yeah, one important rule, don't send out $10,000 of electronic equipment in a cardboard box that Amir found in the street. This is what happened to us. Export issue, we broke our PCI Express in the very strong deep learning machine we bought, and the fan also broke, but we still had a lot of smiles. And we actually built our interior unit, strong GPU, touch screen, all the best and latest of technologies. Ate some fish soup, it was delicious. Just kidding, I got sick on board and I had like a flu, like a fever of like 40 degrees. And now we start to collect data. That's great, right? No. Yeah, most of the data actually looks like this. I mean, 5% is actually meaningful and the rest is just sea and sky. Nothing to see here. Great. Okay, so we have a problem. The problem is that the marine, I'll explain the problem slowly for everyone to understand. So let's say that the marine domain actually changes once every 10 minutes, okay? Every 10 minutes, the sun moves a little bit in the sky, the wind change, something interesting might have happened. So let's say that every 10 minutes, we take a snapshot of the world, collect data from all the sensors of the ship, and collect all the images that are there, because nothing changes, really. So this generates roughly 20 gigabytes of data per month. Out of that, only 5% has any meaning. So you fly to Spain on 3 different flights, you install a system on a ship, you go on sailing for 4 days, connect everything at the office, you sit in Tel Aviv, you see all the data comes in, and out of it, just maybe one gigabyte of meaningful data that's actually good for your system, that actually is suitable for learning. That's a lot of overhead, and that's actually a lot of garbage data just for that. So another problem that we have on board a ship is that it sails at sea, right? So how do you send frames from France to, I don't know, a server maybe in Paris, right? You could use satellite communication, which costs billions for 10 kilobytes. And you can use 4G communication like our smartphones, right? So we did just that. We bought a SIM, international SIM. We put a dongle, started collecting data. But we figured out that out of the whole sail, all the voyage, the actual time of connectivity using 4G reception near shore is very, very little, especially in ships that are doing like cross-ocean sails, right? And along the way, you see a lot of stuff. Other than that, if we understand that the connectivity is very short, we need to upload the most meaningful data first to a server so you can continue training your deep learning algorithms, right? So now we tackle the question of what is important at sea. Is everything important? Is nothing important? Every time someone touches the wheel, is that important? I don't know. So we figured out, put some logic in it, asked some captains, hey man, what is dangerous? And he said, yeah, if I need to intervene, if I have a lot of ships near me, and if I almost collided with someone, that's meaningful and interesting. And we said, okay, this is important, so let's try to tackle that. Code, A lot of people here are from the marine domain, which is great. A little bit of code, just simple example of how to create adaptive frame rate saving algorithm. Very simple idea. So let's say you have an object detection algorithm that detects other ships at sea, and it works pretty good. Let's say that we all the time run this algorithm and search for objects. Once we detected an object, let's check out its speed because it moves a long time. So let's say you figure out the threshold for the speed, and you say if the speed of the object is, I don't know, above threshold, we'll start collecting and aggregating data every second. Let's take a lot of snapshots. It's fast, it's moving fast, it's changing in the environment, it's getting larger, it has a trail, something interesting changed in the environment. All right, and what happened if the vessel is slow? Maybe we'll just collect every like 5 times a minute. This, I think it's a good enough. The world doesn't change a lot at sea. And other than that, maybe we'll still collect every 10 minutes. So guys, this is actually one of the part of our algorithm for adaptive data collection. We're actually working on some very interesting things using the AIS, for example, because the AIS lets us know where are the objects near us, right? So if we have a lot of AIS targets, maybe we'll also start the priority queue. And this is what you get. You get kind of a product that says the most important data will dequeue on connectivity. This is the fast object. They change a lot, maybe near ports. And the least important parts of the voyage, the background, what you saw, the sea and sky, they are enqueuing at the end. What does this do? So you have short connectivity windows. But remember, you have very long digestion time on board the ship, right? 4 days, strong GPU. Why not take advantage of crunching all these numbers to just get the most meaningful data first? So this is what you actually get after maybe implementing this algorithm. You get some, we put a thermal camera as well because it's very good against fog, haze, and opens your eyes at night. Our next system will have 3 thermal cameras. Yay. So start collecting data, and you can see some very interesting edge cases, right? So visibility conditions, near ports, all of a sudden, you're seeing a lot of interesting things, but this is still painfully slow. Are there any shortcuts? Can we do something faster? Yes, we can. Play video games, right? So simulators are actually quite a good way of collecting data, right? If it's good enough for us, why is it good enough for the computer, for the algorithm, right? So playing simulators using scripts that actually change the environment, change the weather, change the time of day, change everything, plant different objects with the respective bounding boxes for the algorithm to say, hey, this is a sailing vessel, this is also a sailing vessel, this is maybe a tanker, I don't know. But using this kind of let's say, groundbreaking technology, even though it's not that much, but it actually allows and enriches your data set to a lot of edge cases, which is very good for us. It even allows us to generate some harsh weather conditions like fog and maybe near shore, and it's still work in progress. But it's scalable and it can be used on the fly while training in the millions, which is pretty awesome. A lot of examples. All right, so one almost last issue about using and putting a high-tech deep learning black box on a ship is the reliability issue. Like I told before, no one will let you put your black box that I don't know why it turned right on the huge ship. You need to build something really reliable. And this is actually the challenge that Orca is facing every day. The challenge is, first of all, how to build a system that could aid commercial ships that are shipping millions of dollars per voyage in the most reliable way possible. First of all, when I talk about reliability, let's talk about, yeah, the software needs to work. It cannot crash, cannot have any lags. It needs to be sustainable, needs to be great. What does it mean? It means that you need to be able to remote update your system. This is a challenge. And the second challenge is actually detecting everything. You cannot afford misdetections and false alarms and I don't know what. Birds all over the place. Yes, this is a ship. No, this is bad. We cannot afford that. So I'll talk about these two topics. And like I mentioned before, the challenge here is introducing the old-fashioned maritime industry with new technology. About reliability, again, a little bit, it's not code, it's more of an architecture. So yeah, state-of-the-art, Docker, containers. We actually build our entire system using the microservices architecture, where each of our modules, of our sub-modules, is actually very reliable, I would say black box, and it's interchangeable. What does it mean? Tomorrow, a new detector algorithms comes out to the market, no problem. Our contained environment is written in any language you want. It could be C, C++, it could be Python, it could be Keras, PyTorch, whatever. We can just interchange it with ease. Second of all, it's very easy to monitor. We can know, we can tell if the, for example, the communication engine fell down. Oh shit, I need to raise it up. I need to fix. I need to provide a hot fix. And on failing, this is the most important aspect. The entire stack doesn't crash. I mean, the system still runs. You still can use the system. You still collect data, but maybe you don't see any other ships. In another case, maybe you see the ships, you still can collect data, but you're not, I don't know, perform visual analysis on the image. I don't know. So the idea is microservices and everything is actually stored on S3 in AWS. More about reliability. So this is actually footage from our own MongoDB. We follow the ship. If Windward is doing it in the macro global level, we're actually doing it in the micro ship level. So maybe collaboration over there. Big company. Yeah. We're also monitoring how many nautical miles the ship has sailed, the communication, everything we want. And we can never forget the human in the loop. We need to allow the humans, they are bad people, we need to allow them and involve them in the development process, because we need to introduce how our technology works so they can actually see with their own eyes, even though maybe one day autonomous ships will not have anyone at all, so you don't even need screens. But until we get there, it'll take a lot of time. We need to introduce them, hey, Captain, this is a ship. Is this correct? Use the captains as validation for our data. Why not? He doesn't know how it works. So what's next for the incoming future for Orca AI? Of course, more installation on more ships. We need more data. By the end of the month, we're going to be installing on a second ship. Tamir is resisting it because it stops at Turkey, and he doesn't want to go out at the port at Turkey. He's afraid of the Turkish. We're actually building the most meaningful data sets of the marine domain, of the visual domain, which is something that's not a thing yet. We're talking about sensor fusion, so cameras to AIS, cameras to radar, already working and building that. We talked about a little bit car-to-car, predictive maintenance. The guys over Windward talked about ship-to-VEC, interesting, and ship-to-ship. I'm talking about a true interconnected ship-to-ship sharing of information, of interesting information. For example, one ship saw a human in distress, but it couldn't stop. So it shares this data with maybe other ships. It saw a container. It saw an iceberg, something that doesn't even have AIS data, right? Next on, we're going to work hard, relentlessly on alerts based on semantic understanding of the scene. What do I mean by that? It's not enough just to understand that I am near a port. There is a vessel over there. I'm going to be stumbling a ship in a couple of minutes. We actually want to create a context database, which means, hey, Captain, it's dark outside, the visibility is low, you're entering Singapore, and you have 50 vessels in front of you. We recommend that you slow down a bit. This is the idea of the contextual database. So these are actually the alerts and navigation recommendations, kind of a co-pilot, if you'd like. And last but not least, the Autonomous Ships Challenge, which is not only about autonomous navigation, it's also about predictive maintenance. It's also about remote control, remote monitoring. What happens if you have pirates along the way? What happens if a thunder struck the ship and all the system collapses? So autonomous ships probably are coming, but it'll take a couple of years to get there. So we are building the building block, the platform for the brain. This is the idea. Thank you, guys. Let's catch up. I'm over here. I have how you call this card? It's still a thing, right? This one. I have a lot of these. We're looking for great engineers, software engineers, algorithm engineers, system engineers, and let's catch up. And we are here to stay, so hopefully we'll do some great things. Thank you, Hanan from the doc, for coming here. The doc are actually some of our investors, and we're looking forward in the shift in the maritime domain, especially in Israel. We have a lot of great assets here, a lot of great people, and I think we're going to grow and do some really amazing things. Thank you very much. Yes. Hi. Yeah, so it's an ongoing effort. So what she asks is, are we augmentating the synthetic data with the real data and trying to figure out the best mixture? So yeah, of course. This is one of the first efforts that we put. So the entire paradigm of simulators is that it will get you to a certain point of capability, and from there you need to complete it using real data. So because we started by building the data collection platform, and while we're at it, we're actually involving the synthetic data, it's now a matter of research and R&D. We have only just one algorithm engineer is doing a lot of things. So finding the correct mixture of what data, what model, what hyperparameters, this is a work of art, and it will take us time, but we'll get there. Another question.
One moment, I would just want to answer you because you say to us. We are sailing 7 years around the world, and we came with our boat to Australia from here.
Yes.
Here's an idea for you. When you say car-to-car communication, more or less, the cars have more or less a similar shape, similar size. You say ship-to-ship communication to prevent collisions. You might want to send more information about the shape of the ship, the size of the ship, the geometry of the ship.
Yeah, that's correct, and that's
an interesting idea for you.
That's interesting, and that's given free using the great AIS, which actually gives you the type of vessel, usually the size, the length, the berth, everything you need to know. It's a work in progress. Ship to ship will happen when we have installed our system on more ships. It happens today using radio frequencies, communications, but the idea is maybe generating a true network of interconnected ships that collaborate and work together.
Maybe also the angle of the ships.
Yeah, it's a great idea. Thank you so much. Yes?
So two questions actually. One is regard to transfer learning with respect to simulated data to real world scenarios. How good it is in general, not necessarily in the ship domain. And the other thing is with regard to the priority of the data. I would think of it that you don't want only the fast before the slow, but you want kind of mixture which wait more about the fast and take also from the slow. Otherwise, you might have missed all this slow moving. You won't learn anything slow.
Yeah, so learning something slow is super important. What I showed you here is just a partial solution of our algorithm, just to give you the concept of not collecting everything because it's not meaningful. But thank you for that. And for the augmentations of the synthetic data, so it's a hard question to answer because our systems are actually learning the contours, the shapes, the colors, all of this in the deep learning algorithm, but we cannot know for sure how much it improved. So if you try to train only on synthetic data, you get mediocre results on our own benchmark, which consists of true images collected from the ship in a more generalized environment, in harsh weather conditions, different visibilities, which is pretty hard. And just training using our own collected data is also getting us not such a high score because you need more samples, and we're just collecting the samples now. It will take us time.
Maybe using some kind of gun, like the new...
We thought about using GANs to transform simulated data into real-looking data, and also for super resolution, which is also pretty awesome. But thank you, and I'm out of time, so thank you very much again. Hope to see you again. Thank you, Dalia.